Hey guys, so let me go ahead and say my joke about the fact that I'm the same Jeff. It wasn't my evil twin that was teaching the first so many weeks. I just got tired of the beard. I might grow some of it back. We'll find out. So just to address that off the bat. I have a question on the table from section 4.3. Let me throw it up here. This is number 85. So if I said, all right, so first off, I don't know how many of you guys have tried this problem out yet. Right, so let's look at a couple of things. Can somebody tell me out of this problem here? So a nurse commented that when a patient calls claiming to have the flu, the chance they do is only about 4%. Of the next 25 patients calling in, we're interested in how many actually have the flu. So can somebody figure out what's N?
P5.
Yeah, so N is going to be 25. What's P?
0.04.
0.04. And what's Q?
0.96.
I love it. All right, so those things you have to be able to identify relatively quickly. They have to just give you this. You just have to see it and realize that it's a binomial situation. Either they're going to have the flu or they won't. And I can see an N. I can see a probability of something. So there must be a probability of not that something. So it kind of calls out to me that it's what I call an NPQ problem. It's a binomial problem. So this one says find the probability that. So what if I ask you, what's the probability that exactly 3 have the flu? How would you set up that formula for this, knowing these things? So I'm not doing this problem. I'm making it my own problem because I can. Anybody? What's the formula for
25.
Yeah, so I have 25 people and I want to
Choose 3.
choose 3 of them to be a success. So of course I'm going to have 3 successes and the rest, which would be how many?
22.
22 would be failures. So let me stop for a minute. You guys okay with that? Okay, all right. I got nothing I keep looking down here at your name like it's going to tell me something, but and blah, blah, blah. So that's not even the problem. So here, does this say exactly 3 or exactly something, number 85? Oh, there's somebody chatting at me. Oh, who knows? It sounds close enough to me. But I don't know. They have some typo somewhere. I don't think this is a typo, so let's find out what happened. This one says at least 4. What does at least 4 mean?
Four or more?
Yes. So it'll be 4, 5, 6, 7, 8, 9. I don't even want to write them all out. Do I want to do a formula? So one way to do this is to do this formula for 4, 5, 6, 7, 8, 9, up to 25, add them all up. Completely valid. You could do it that way. Does anyone want to do it that way? I mean, you can. Nothing wrong with it, except for the fact that it's a big waste of time, because what's the opposite of at least 4?
Anything below 4? So 1, 2, and 3?
You left 1 out. Yeah, everybody always forget poor 0. So if I can figure out the probability of 0, the probability using this formula, probably 0, probably 1, probably 2, and the probability of 3 is sitting right there. Add them up, and then that would be the opposite of what the question wants. So if I can calculate the opposite of what it wants, the question gets angry. What are you doing? Then we do 1 minus, and it's like, oh, okay. I know it's a dumb joke. I don't care. I love it. So answer the opposite of what they want and then do 1 minus that. Why would I ever do that? Because this is a lot less work, right? This one, I got to do a formula for each one up to 20. Screw that. Let me do 0, 1, 2, 3. I can do that formula 4 times. What to do? If anyone's using binomial CDF bullshit, stop. Bullshit. So I think I told you that this book relies on the calculator too much, and it's you that needs to be graded for your work. So let's not push too many buttons. You can use it to check your work all day long. I don't mind that at all. You better show me something though. Is that all right? Or, is that understood? I don't care if you think it's all right. Is that understood? Maybe. Is that not understood? Anybody? My last teacher let me do it. I don't care. I'm not your last teacher. Okay. Anything else? Any other questions? Oh, sure. So I don't know, Frida. It sounds too close to be something's wrong. So I don't know. I don't know if you, I'm not sure if that's one of the ones that's a typo. If you did all this work that I just showed you, then you should be fine. Oh, okay. All right. Anybody else? Questions?
Could we go over 70 from 4.2 homework?
Let's see. Oh, good. All right. This is a question that if I don't get asked this question, I get a little concerned. This definitely had a lot of you guys just going alone and saying, what are the possible outcomes of this situation that 70 details? What are the possible outcomes?
You win or you lose.
Beautiful. So that's what you're interested in. You're interested in what you could win, right? So what values can X take on then if it's all about whether you win or lose, and that's related to how much that thing is worth? What could happen? There's two things that could happen here, right? You win or you lose. What happens if you win?
You get Broadway tickets.
And how does that translate into cash? I'm only interested in cash.
150.
150.
150. I'm not going to write that down yet. And if you lose, what do you get?
Negative whatever you spent on raffle tickets.
Okay, so think about it. I like that you said that. So this will be negative. How much am I going to spend? They're $5 a piece, and I bought 4. How much am I spending?
Negative 20.
Yeah, so I'm going to lose 20 if I lose, right? I'm out 20 bucks. Okay, I like it. Somebody was chatting at me. Sorry. So be careful. I'm not going to win 150, am I? Because if I win, I still had to pay 20 bucks. So how much am I really going to win overall?
130.
130. So X needs to be related to all the possible outcomes or something. So if, so it can't be, somebody was putting 1, 2, 3, 4 for the number of tickets. The number of tickets is not unknown. 4, you bought 4 tickets. That can't be a random variable. Where does 4 come into play though? What do I still need to fill in so I can eventually figure out the expected value? That's neato. What does that look like to you guys? I have no idea. All right. Anybody? What's the probability that you win? That's what I need here, right? Probability of those things. What's the probability that you win?
4 out of 100.
Yeah, you bought 4 tickets and there's 100 tickets. There's a 4 out of 100 chance. So it's probably you lose.
96 out of 100.
96 out of 100. Become 100. All right, somebody's chatting at me. Oh, 36.42. Okay, all right. And then you can do the expected value very easily, right? So if you can take, so there's another situation I think in here somewhere where you have to set up your own table, right? But if you can set up the x's and the p of x's, then you just multiply, add, find the expected value, the average. All right. How you guys doing out there? You okay? You guys doing all right? By the way, I don't know if I said this last time. What's supposed to be happening today from the original plan?
Our quiz.
Quiz.
Yeah, it's not happening today. So I don't know if I said that. Obviously, because I had to push the last quiz back. So this quiz I'm pushing back to Wednesday. Okay, all right. Let's see. Is that all right for that problem? That should be all right. It's basically done. You just got to do a couple of calculations. I just got another question. Let me see, where'd it go? Number 36, all right. I'm gonna clear all these drawings away. Go away, gone. Okay. So another question is 36. Oh, there it is. So I'm not going to do this one for you. I just did the other one for you. So this is the same idea, number 36, exactly like we just did. The only difference is I don't have to play. I don't have to pay to play. I can just play. I have to pay if I lose. That's the deal. So can you construct an x p of x table? Whoever asked that question, does that help at all? If you can put together. So what are the two things that could happen in English? You could either
You win or you're paid.
yes, good. You win or you lose. And if you win, can you give me a number that goes with that? And if you lose, can you give me a number that goes with that? So those would be the X's. And then if you win, can you give me a probability of that? And you put that right next to the X. If you lose, can you give me a probability of that? So it's sort of like this. Let me see. Let me give you a situation. If I came up to you and I said, "Hey, if you give me $5, right? There's a chance you could win $10." Right there, it's almost enough information for you to say, "I ain't doing that shit." I don't know if you guys, I shouldn't have said that, but you guys agree with me? If I said, if you give me $5, there's a chance you can win 10. That's almost enough information to say I'm not even going to play that game. Are you guys with me? Everybody, I don't know what you guys are all doing. Everybody's busy that I can see. But watch this. If I said, all right, so here's the question. Here's a really good question. If you could win $1 million, if you could win $1 million in some kind of a raffle or some kind of a contest, how much money would you pay to play? Right? And then there's even another, so I could actually do some work to see how much I would pay to play to make $1 million. It also has to deal with, do you have any money at all laying around? Because the old adage about you need money to make money is so true, which is why, everything is completely unfair. But what if I said this? What if I said I got a bag? Now stay with me. I'm gonna work on this problem a little bit more. These problems were not very interesting. I got a bag and there's one white marble and there are 99 blue marbles, right? And if you pick the white marble, I will give you $100. But if you pick the blue marble, then you have to pay me $2, right? Can you tell if that's a good game to play just by what I've told you?
No.
No, I can't. So this expected value, what it does is it brings together the probabilities and the amounts you win or lose each time. And it kind of gives you, so if it comes out positive, it's overall a good thing to do, especially if you're going to do it over and over and over again, which is why if anybody plays poker, if you're actually entering poker tournaments, you do this kind of evaluation. Because if you're going to enter many, the way you play might be different because you're playing the long game now. So you're okay with losing a few tournaments because you're almost guaranteed to eventually win a decent amount of money in the long run if your expected value is positive. All right. Let me give one more idea. Let's see. So if there was if the probability of winning something was 0.0001%, do you think you would play that game?
No.
And I tell you, you have no idea. What if the
Just
game,
lotteries.
but listen, what if the game was, if you win $50 million?
So basically the lottery.
Sure, but it costs 1 cent to play. Do you still feel the same? So if I had just stopped right here, I think a lot of you guys would have said, I'm never going to play that damn game. That's almost impossible to win. But if it costs a cent and you might get $50 million if you win, I'm going to throw a few pennies at that damn game. Do you guys understand? So the chance of you winning is so small, but the amount of money you lose is also very small. Okay, maybe. So that's why you have to bring together the X's and the P of X's. You have to bring together the values that relate to the outcomes and the probability of those outcomes. They have to work together. Either one that I know by itself is not enough. If I just know this, that's not enough information to tell me if I should do it or not. It's just not enough information. If the probability of winning is this, and I win $1, and it costs 98 cents to play. No, are you kidding me? I'm never playing that freaking game. But this game that I've set up, I would hope that most of you would play that damn game. We all have a couple pennies floating around on the bottom of our car, or at least we used to when we used to drive around a lot. No, yes, maybe, no, maybe, no, maybe. So that's why this whole idea of bringing those together to make a decision makes sense. Okay. All right. So hopefully that's enough for number 36, because all I'm going to say. It's exactly like the last one we did, right? So you have a win, you have a lose. Those are the two things that could happen. Oh, this is awesome, Jeff. And you have a outcome number, and you have a probability of each. So then you can just do X times P of X, add them up. Something that's driving me a little crazy too. I've been grading some of these. Let me clear all this chicken scratch up here. Clear. There's a problem early on. Let's see, it's really early on. It might be this one. I don't know. Or is it this one? It might be this one, yeah. Where they ask you to find the average for this, and there's people telling me it's 3, or people just telling me it's 2 with no work. I mean, what the shit? How do I find, what's the average mean in this kind of problem? What do I have to figure out to find, what's the mean in this case? What's the formula for the mean for XP of X problem?
Is it X times P of X and the sum of that?
Yes.
Okay.
EXP, expected value, right? So if you, I would rather, so some of you guys are doing that work, but you're not doing it in the table. I do want you to do it in the table to get used to that. So you just do X times P of X and put it there, and X times P of X, and add them all up. That's the average. I think one poor person did this, and I think that's because, no, don't do that. I did say what is already on the bottom of P. What's on the bottom of every probability? What's on the bottom of a probability?
100?
No.
N.
Thanks for playing. N. Yes. If I have 57 people and 11 of them are left-handed, it's 11 out of 57. That's N on the bottom. So the n is built into this. You don't put it there. It's already in there. So that's why it's the same formula as what it used to be. That was my point, was showing you that. Okay, maybe. Okay. So let's see, anything else? Did I miss anything in chat for questions? No. Okay. All right, so what I want to do, let me know if anybody else has a question. I want to show you something that I added into, there we go. I added into our Canvas. I don't know if you guys have been on there recently. If you have been, remember here's where my extra office hours are. So if you just click on modules in our 160 class, you come here. These two are new. They have finally, we as a math department got together. We structured the tutoring so you could actually just do drop-in tutoring. So if you go here, you can read about it. They have instructions. They have is this a video too? View the instructions. I thought they had a video. Okay, maybe not. Yeah, okay. So this is for drop-in tutoring. So here's the tutoring link. So if you click this button, you get sent to this room, this Zoom room, and the guy says, or the girl, whoever's working there says, what do you need help with? And you say statistics, and they'll put you into the statistics breakout room. And a tutor will be there helping people with statistics. Are you guys with me? That sounds like what the Math Study Center used to be, right? So we finally figured out, and we finally got a little more funding to make this happen. So do consider that. That's beautiful. You just drop in, you tell them you're there for statistics. They put you in a room with some other statistics people. You can either talk to them and get help if the tutor is out somewhere. The tutor comes in, he asks you questions. I think there's still a sign-in. They do like a virtual sign-in thing so you can sign your name if you have a question. Is everybody understanding that idea? You understand it better if you ever went to the Math Study Center or before, back in the days, way in the before times when we had we were in like a building for this kind of stuff. Okay. And of course we also have by appointment tutoring. So you can click there if you want to make an appointment for tutoring, blah, 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 blah. They got all kinds of stuff here for that. So I'm gonna let you guys look through that. Okay. All right. Any questions on the tutoring stuff? Okay. And then I added something else. Okay, here we go. I added a few things. So what I want to start with is this guy. So if you can access Canvas, I have no idea where that came from. Do that and go here. Binomial and uniform practice. Yeah, baby. So I want you guys to work on this. Yes. So is anyone not able to access that? So again, it's under modules. You go to unit 5. Where'd you go? Oh shit, did I put it way down here? I did. Let me move this up here. That's good, Jeff. All right, here we go. Now it's right after 4. That's crazy. That's awesome how that works. Numbers. I don't understand numbers. All right, let's see. There we go. So now we got 4, 5, 6. Look how much sense that makes. And now you should be able to find that. All right, let me share it with you guys if somebody needs to. I'm going to share it this way. Oh shit, I got to put this over there. So everybody understand what you're supposed to be doing right now. So this is up to you. You can either just sit there and not do it and not get shit from it, or you can try this out, make some mistakes maybe, and then, know how the hell to do shit when you have to do it yourself. I'm going to stop recording for a bit. Let me scroll up so that the recording can capture what we've done. Yeah, I didn't mean to do that. Sorry. If somebody notices that, just let me know. I obviously turned it off when you guys were working. So for those people that are watching this in the future, I'm sorry. Is things better in the future? I really hope so. If they're worse, I don't know what the shit's happened. Have the apes taken over? I don't know. All right. Planet of the Apes. All right. Sorry, we got to finish this one out. So what is this will be what? This will be, what's the base? What's the base? How long is the base?
5 minus 1.
4.
4 times the height. So it's the same answer we just got earlier. Same probability. And that's not very uncommon in a uniform probability. It's sort of like you roll a die, all the sides have the same probability. That's what uniform means, right? Everybody gets the same probability. But it's not that this is always going to happen. Don't get me wrong. These two are kind of special cases. What's the probability it'll take me more than 12 minutes? You can see it from the picture. I mean, what's probably going to take me more than 12 minutes?
0.
0. It's no hide out there. It's impossible. Because after 12 minutes, I just stop looking. I just stay where I am. Not. Now, here's the freakiest question on here. What is the, so when I have a picture like this, when I have a probability distribution graphed out, what is the answer to any probability question related to? The answer to this probability question was, what is it related to visually? What did we find each of these? Say again.
The area in the box.
Area, exactly. It's related to the area that I get when I draw the question on the picture. So look at what this says. This says the probability x equals 8. What would that look like if I drew that in?
Just like a sliver?
A sliver, sure. So what is the area of this? Well, how long is this?
Oh.
It goes all the way, sorry, say again.
Oh, 0?
0.
Oh,
So the probability of any individual thing is 0. Now, another way to look at that, without getting overly freaky, how many numbers are between 1 and 12? I don't know if you can consider this a trick question. I said how many numbers, didn't I? I didn't say how many integers. Say again, sorry. Oh, infinite, there it is. So doesn't it make sense the probability of any specific thing is going to be that 1 out of infinity, which is basically 0. 1 divided by the biggest number is the smallest number. That's another way to look at that. Now, to be really, 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 really honest, you do not have to listen to me right now, but if you're curious, you can look up the idea of iota. Iota is kind of like the opposite of infinity. But if you don't care about that, then the answer here is 0. The probability x equals something is effectively 0 because there's an infinite number of things that could happen.
could you please explain it again, please?
Could 7.929964 happen? Yes, it's in here, isn't it? It's in here. Could 1.0000004? Yeah, it's in here. It's in here, right? So how many things are in here? How many possibilities? There's an infinite number. So therefore, the probability of any one thing out of an infinite number is basically 0. There's 0 chance. Maybe. But another way to see it is if the area is equal to the probability, a line has no area. 0, bam, done. That's maybe a little bit easier way to look at it. That's why these had answers. There's an actual area associated with them. This one, 0 answer because there's no area. Okay, maybe. So that's going to happen. And
It's
sorry?
hard to understand.
so, all right, you need right now, you desperately need to understand that whatever the distribution looks like, if I make the total area 1, then the answer to any questions is just the area of that question. Just like we did here,
Mhm.
And the area of 8, well, it goes from 8 to 8. Like this went from 1 to 5, so that's 4. This one's from 11, that's 4. This goes from 8 to 8, that's 0. No question.
Mm.
Done.
Oh.
So there's a few different ways. You can look at it geometrically, or you can look at it probabilistically. Ooh.
Okay, thank you.
You're welcome. It's freaky. I will guarantee you that. I will grant you that is freaky. All right. Okay,
Wait,
that's enough of that.
hold
Yeah, I'm
on.
sorry.
To clarify,
Yes.
I got confused in the middle of that. To clarify, since it's 8, since 8 is only 8, it'll be 0 because it's by itself. It's not arranged like 1 to 4.
Yes, so therefore it's the width of this is 0. So the area is automatically 0. And since the
Okay.
probability equals the area, the probability is 0.
Okay, got
I
it.
like it. So I want to show you something kind of freaky, like I always do. And then I'll probably let us out after I say this, because it's already 3 and I haven't really given you a break. It's almost 3. I'm going to stop sharing because I don't like sharing. This is hard for me. All right. And then I'm going to go up here to the board. Oh shit, let me spotlight myself because I want the whole limelight to myself. It's mine. All right. So I kind of want to hammer this home a little bit. No matter what, there are actually probability distributions that look like triangles.
Can you move
Holy
the-
shit. I'm with you. I just had to look at it. I'm like, oh shit. So there are probability distributions. So we have the uniform one, which is the most kick-ass distribution because it's a rectangle and areas are easy. But there are probability distributions that are triangular. And so I'm not going to do this whole problem because we don't have to worry about triangular ones, but I just want you guys to realize if I wanted to know what this from 3 to 4, I would find the area of this. Now I have to figure out what the height is. And that means, so what's the base of this triangle? It's 6. Let's see if we can handle this. What's the area of a triangle? What's the formula for the area of a triangle?
Base times height divided by 2.
Yeah, 1/2 base times height. So far I got 1/2, and I want the area. What do I want the area of this whole thing to be? What's the whole thing got to be for this to work? The area of the whole thing. Sorry? 1, exactly. That's related to all the probabilities adding up to 1. So if I have the picture of the distribution and I can make the area 1, so I got the base is 6. I know the area wants to be 1. I can solve for the height. 6 divided by 2 is 3. If I divide by 3, I get 1/3. So now I know what the height is. And then this problem gets way too ugly for us to do. I at least wanted to show you that. And then what's the shape? What's the shape, by the way? Does anybody know what the shape is?
Trapezoid.
Trapezoid, because there are 2 sides that are parallel. And the other 2 are doing whatever the hell they want to do. And I could look at the area of the trapezoid formula. I could figure out, it's 1 here. I got to figure out what these are, which I could actually do. It's not a very easy problem, but my point is not to do this whole problem. My point is just, it doesn't matter what the shape of the thing is. If I make the whole area 1, then any probability question, what's probably between 3 and 4, becomes find the area of this shape. So what we're about to get into is something a little worse than rectangles and triangles. We're about to get into this. Not this, sorry. We're not gonna do los espookies or something, right? We're gonna do normal distribution. So what's wrong with this shape? If I wanna find the probability is from here to here, that's not a trapezoid, is it? Because one side is curvy. Oh shit, I almost destroyed my board. One side is curvy, so I'm gonna need some help. The same idea applies. If I could find the area of this, I could answer this question, which might be, like -2 to -1. Remember this, these are all z-scores. So if I want to know what the probability, I just have to figure out the area of this, but this is beyond our geometry. That's not some shape that I know. It's not a trapezoid because one side is curved. So what we're gonna do is we're gonna use charts that some calculus helped us do. We're not gonna learn calculus. We're just gonna use some charts with a bunch of numbers on them that tell me the areas in the normal curve. All right, so that's what we're gonna definitely do next time. I just wanna show you, this is the last thing I'll do with you. I wanna show you that I've posted a couple things up here. Oh shit. No, I don't want you, Microsoft Store, stop it. All right. Get in there. So if you scroll down, if you look at 6, there's this chart. You do not have to look at this much yet, but just want to show you what's up here. You might as well print it out for next time and look at all the detail. Oh, dude, look at all that detail, dude. What the shit, Jeff? And then there's the negative side, if it'll load. There it is. No, it isn't. That's positive again. Well, that sucks. Did I do the wrong thing? No, I didn't. Thank God. Anyway, sorry. So just to show you, if you want to go ahead and print that out, you don't have to look at it much yet. I'll explain next time what it means. But what it does is it finds the areas that we cannot calculate on a normal curve. It helps us out. But the idea doesn't change. The area is equal to the probability that that represents. That is so beautiful. So next time we're going to get into chapter 6 and we'll take a look at that chart. And I have a handout that's up there too. If you want to print that out before next time, you can. Otherwise, I think that's enough. I didn't give you a break so we can leave a little early. Somebody have a problem with that? I always like to ask that question. Somebody, I think I told you somebody got offended that I'll let people out early. I'll pay you this time. Holy shit. That's enough for me though. If anybody needs to hang out and ask questions, let me know. Otherwise, you're free. Yes?
So for D on the practice, it was 0 because there is nothing after 12.
Yes. If the answer is the area and there's no height after 12, then there's no way. So that's got to be 0. There's no way it can have an area.
Okay, so if 0 minutes is also 0 because you don't even take, like, it takes you a minute.
Yeah, for some reason in this problem, the way it's set up, I take exactly 1 minute up to 12 minutes uniformly. So the least amount of time I take is a minute. So if I said what's probably it takes me anywhere from half a minute to 3/4 of a minute, the answer would be 0 because the height in that place is 0. There's no area. Yeah. So that's just the reminder. The area is the probability. So if there's an area where there is no probability, like above 12, below 1, there is no height, there can be no probability. It can only be 0 probability for that because it can't have any area out there. I like it.
Got it.
Yahar, yeah, it's gonna be the same as last time. Like the last quiz, exactly. Yeah, because I can't come to find out with this, the way we're doing things, it just takes me longer to get through things. So I can't use class time for those, I've discovered. Anybody else have questions? You guys all right? No, I'm gonna head out if there's no questions. Get me some lunch. Oh, happy birthday. I just had my birthday too. All right. think I might be a little older. All right, guys. See you.